I am Anil Kumar Khandelwal. Welcome to some of the questions from our book, Rediscover Algebra and Trigonometry. We'll prove the following trigonometric identity, which is sine square x plus 2 cos x minus 1 over sine square x plus 3 cos x minus 3 equals to cos square x plus cos x minus sine square x. To prove identities, we could start from left side or right side. Now in this particular case, let me begin from the left hand side and we will show that it is equal to the right hand side. The left hand side given to us is sine square x plus 2 cos x minus 1 over sine square x plus 3 cos x minus 3. What we notice is that the right hand side is practically in cosine. So it is a good practice to convert sine square x into cos square x. We can always write this as 1 minus cos square x, right? Since you know that sine square x plus cos square x equals to 1. So that means sine square x is equal to 1 minus cos square x. So we are going to use that identity here, Pythagorean trigonometric identity. Writing sine square x as 1 minus cos square x plus 2 cos x minus 1 over 1 minus cos square x plus 3 cos x minus 3. Now, in the next line, we'll further simplify. 1 and minus 1 cancels. So we get minus cos square x plus 2 cos x. In the denominator, we get 1 and minus 3 becomes minus 2. We get minus cos square x plus 3 cos x minus 2. Now from the numerator, I can take minus cos x as common, which gives me cos x plus becomes, because we took minus cos x, we get minus 2. In the denominator, we could also factor negative and see we can apply product and sum rule, right? So we need a product of plus 2 sum of 3, right? So that we can get by 2 and 3. So we could factor this as minus cos x minus 2 times cos x minus 1. Now we have a common factor which cancels, and that minus minus also cancels. So we are left with cos x over cos x minus 1. In the right hand side, we are looking for sine square x with the negative sign in the denominator and the two terms cos square x plus cos x. That means if I take cos x common, I get cos x plus 1. So we can rationalize, right? So let's rationalize and continue. So we have cos x over cos x minus 1. Rationalization means multiplying by the conjugate, this case the denominator, which is cos x plus 1 cos x plus 1. So when you multiply and divide by the same thing, you're multiplying by 1. So it doesn't really change the equation. So the numerator now becomes cos square x. We can write cos x times cos x plus 1, which is cos square x plus cos x. And in the denominator, we get cos square x minus 1. Now, cos square x minus 1 is minus sine square x, right? As you can see here, Sine square x is 1 minus cos square x. So cos square x minus 1 will be minus sine square x, right? So we get minus sine square x as required. And numerator you can expand cos square x plus cos x. So we get this as equal to, so that implies that left hand side is equal to right hand side. And that is how we are going to prove this identity. Simple steps. Using sine square x plus cos square x equals to 1, we can actually prove this identity, and some factoring skills, of course. I hope you understand and appreciate it. About the book, you can always send an email on globalmathsinstitute@gmail.com.